Hello and welcome back to another video. In this problem, we're told that some of the highest tides in the world occur in the Bay of Fundy on the Atlantic coast of Canada. At Hopewell Cape, the water depth at low tide is about 2 meters, and at high tide it is about 12 meters. The natural period of oscillation is about 12 hours, and on June 30th, 2009, high tide occurred at 6:45 a.m. We're asked to find a function involving the cosine function that models the water depth d of t in meters as a function of time t in hours after midnight on that day. So we have a natural period of oscillation, right? So the tide is varying, so we're starting at high tide, and we have a period of oscillation that looks like the cosine function. Now, we have to do d of t is equal to cosine of t. This is our starting function. Obviously, cosine doesn't perfectly model it because of all these different variables, but we're going to apply transformations to get it to match. So first, let's start with the horizontal shift. The high tide is not at midnight on this particular day. It's at 6:45 a.m. That's right here. The x value on the x-axis, right, is hours after midnight. 6:45 is 6 3/4 hours after midnight, since 45 minutes is 3/4 of an hour. So we're shifting the cosine function to the right, 6.75. So d of t equals cosine of t minus 6.75, right? Applying that horizontal shift. Next, we have the horizontal stretch. The period of oscillation of a cosine function is 2 pi, right? Every 2 pi, the function repeats itself. Here, it's 12 hours. So to get it from 2 pi to 12 hours, we have a horizontal stretch by a factor of 12 over 2 pi. And how that actually formulates in the function is you're multiplying this value by the inverse of that fraction, by 2 pi over 12. Right, you have to multiply it by the flipped version of the fraction in order to get the stretching that you want. That is in contrast to the vertical stretch. So the difference between the lowest point and the highest point on the cosine function is 2. Right? It goes from 1 at its maximum down to its minimum at -1, 2 units away. Here, it's going from 2 meters to 12 meters, so it's going up to 10. So this is a stretch of 10 over 2, which is 5. Here, we're not putting 2 over 10 or 1 over 5. d of t is simply equal to 5 cosine, and then this whole thing here. Before we continue, let's just turn this into 2 pi over 12 is the same as pi over 6 times t minus 6.75, and so on. And finally is the vertical shift. So the average value of the sine function is 0, right? If you take the maximum and the minimum and you divide by 2, you get 1 minus 1 over 2, which is 0. If you do that here, 2 plus 12 over 2, you get 14 over 2, or 7. So that means that it shifted up 7, and it's hovering around that 7, the average tide. So we have to do a vertical shift up 7, so we get 5 cosine of pi over 6, t minus 6.75, parentheses, plus 7. And this is your final function. This models the water depth, d of t, as a function of time t, hours after midnight, on that particular day in this cape, in this bay in Canada.